flying boats caught here in beautiful formation flight were conceived, designed, and built by the Consolidated Aircraft Corporation, and from their inception were destined to become outstanding patrol bombers of the world. Their load-carrying capacity, their speed, range, and reliability have been amply proven in extended flights, and their striking performance won for their builders the largest order of twin-engine flying boats ever placed. More than 200 of these flying ships were built for the United States Navy. In groups of 12, 14, 18, and even 48, these famous planes, flown in formation by United States naval pilots and consistently adding to already impressive records of mechanical performance, have repeatedly demonstrated their ability to travel distances of from 2,500 to well over 3,000 miles non-stop, a truly remarkable record of flying boat stamina and consistent performance. As we fly along, we turn our attention to the home of these graceful boats, San Diego, California, with its ideal year-round flying weather, landlocked harbor, and municipally owned flying field. This is Lindbergh Field, where the Consolidated Aircraft Corporation is located, the birthplace of the PBYs, as these flying boats are officially known. This manufacturing plant has an area of approximately 750,000 square feet of space devoted to the production of these airplanes. Here in the engineering department is grouped one of the outstanding engineering forces in the manufacture of aircraft today. It was from this department that the famous PBY flying boat design emanated. It is here that airplanes are conceived, stressed, and engineered months before they are publicized to be brought carefully, methodically, and painstakingly to perfection. The engineering drawings and specifications are now translated into orders for materials, and the sequence of operations is determined. Meanwhile, quantities of high-grade raw materials are arriving for use in the building of the airplanes. These are carefully unloaded, checked in at the stockroom, given a thorough inspection, and then dispatched to the various departments for the many processes to be performed before the material as finished parts enters the airplane. Into the anodic tanks go all aluminum and aluminum alloy parts for the anodic treatment. This process forms on every surface a protective film of aluminum oxide, a tough, corrosion-resisting basic protection which becomes a part of the metal itself and which makes an excellent base for paint. Inspection plays a highly important part in the production of these record-breaking planes. The inspection department carries on the inspection of every part of the plane, from the raw materials at the very start, straight through each operation, process, and assembly, to the finished PBY as it rolls off the production line. To maintain the highest standard of workmanship, each part and assembly is checked after each manufacturing sequence. Thus, there is built into the plane an insurance for record-breaking performance. Hardness testing machines instantly determine the exact heat-treated qualities of every metal part used in these boats. These machines are both fast and accurate in operation. Micrometers and gauges are used to check fits and tolerances. As a precaution, to ensure that the parts are measured with accurate tools, these checking devices are checked periodically on the super micrometer or master checking device. More than a surface inspection is necessary on the important structural parts. The grain of the metal of which these parts are made must be carefully examined for flaws. Visual inspection will, of course, reveal the obvious flaws, but for these highly loaded steel assemblies, it is important to check for defects that can't be seen. To accomplish this, the simple Magnaflux method is used. First, the steel part is magnetized, then it is placed in an agitated solution of light oil containing powdered iron. After a brief immersion in this solution, the part is removed, and all flaws, even those ordinarily invisible to the naked eye, will be clearly marked with a dark streak. Thus, each airplane structure possesses the ability to take rough handling from either men or the elements, plowing and smashing into rough water at high speed, bouncing and shaking under the impacts, but emerging each time staunch and ready for more without a sign of the pounding it has taken. These automatic rivet-making machines, cutting steadily away at coils of dural wire, biting off exact lengths, upsetting the heads and repeating, can turn out as many as 1 million rivets a week. 1 million rivets per week. Emerging from the machines, the rivets are placed in the heat treat furnace for a timed period, and as they leave the furnace, they are automatically quenched in cold water. When they are subjected to this treatment, they become relatively soft and are in proper condition for use. taken from the automatic heat treating machine, they are stored under low temperature in a large electric refrigerator where they will remain soft indefinitely. If the rivets are exposed to normal temperatures, they soon become hard and develop their full strength. To make them more accessible to the workmen, they are distributed to smaller electric refrigerators located throughout the factory. As needed, the rivets are taken from the refrigerators located adjacent to the work and riveted into place. Within a few hours, the rivets harden and contribute their full strength to the airplane structure. Steel tubing of heavy gauge is run between three powerful rolls to form the engine mount ring. Straight to begin with, the steel tubing is given a slight curvature on the first pass through the machine. Then, each time it is passed between the rolls are tightened a bit more until the desired curvature is secured. Kinking of the tubing is thus prevented, and the tube emerges finally smooth and of the exact radius desired. Most of the metal parts of the planes are formed in the soft or annealed state and must be heat treated to gain their full strength. Soft aluminum alloy parts are soaked in a gas-fired molten salt bath, then quickly removed and quenched in water. When quenched, these parts air harden to develop their full strength within a few hours. Steel parts, according to their composition and ultimate use, receive various heat treatments. Some are quenched in oil. All heat treating is kept under accurate control by a battery of automatic recording pyrometers to ensure uniform results. The steel tube engine mounts are heated in gas-fired furnaces and, when removed, are immediately bolted to a rigid table for air quenching. Bolting the work down during cooling prevents the mounts from warping out of shape. This is the stabilizer unit in the process of assembly. It approaches more nearly its familiar appearance after covering and the fin and stabilizer tips have been added to the unit. The rudders are assembled and riveted up in a vertical jig, and the wing trailing edges for the center section are likewise assembled in the vertical position. All movable control surfaces and the trailing edges of the wings are fabric covered. The cloth used for this purpose is a light, strong, uniform grade of unbleached long staple cotton, and attachment to the surface is accomplished by stitching a reinforcing tape over each rib. A knotted stitch is used which cannot become untied and which serves to evenly distribute the loads and likewise prevent chafing, wearing, or ballooning of the fabric. Hand sewing using a strong wax thread is employed in closing up the control surfaces or to fit around an irregular shape where machine sewing is impractical. By using this method, the fabric is pulled uniformly snug over every portion of the surface. The PBY spars are the main structural members within the wings and are assembled in special jigs. The webbing, aluminum alloy extrusions, fittings, and all other appurtenances produced by the various departments are assembled here. The work accomplished in these assembly fixtures encompasses all of the necessary assembly operations except riveting. Before riveting, the spar is disassembled, sent to the paint department to be anodized and primed. Upon its return, it is reassembled. Screws are used to hold the assembly together temporarily while the rivets are inserted and driven. Cleaned, painted, and riveted, the spars are now complete. From above the wing center section assembly line, some idea of the scope of operations in the building of these units can be gleaned. This part of the plant is devoted exclusively to the assembly of the wing center sections. The leading edges, trailing edges, outer panels, and ailerons are assembled elsewhere. These wing center sections are built in steel assembly fixtures which hold the work in a vertical position so that a number of men can work in a comfortable standing position both on the upper and lower surfaces of the wing at the same time. First placed in the assembly fixture is the rear spar, which is guided into position and made fast in the jig. Then come the wing ribs and bulkheads to give the wing its shape. The bulkheads also form a portion of the integrally built fuel tanks. When all are in place, the front wing beam is brought to the assembly fixture and raised with pneumatic hoists to its position at the top of the fixture. The fuel tanks of the PBY, having a combined capacity of 1,750 gallons, are actually built in as an integral section of the wing structure, a design feature that has several outstanding advantages, one of which is that only a portion of the weight necessary for separately built tanks is required. Although the original airplane of this type established several distance flight records, the standard production PBYs have attained an unequaled reputation for non-stop massed flights over long distances so repeatedly that they are no longer front-page news, but are proof of the progressive engineering built into these airplanes. The wing center section, weighing approximately 1 ton at this stage of assembly, is raised out of the assembly fixture and is transported overhead by monorail to another portion of the assembly line. The 2 black dots in the center of this portion of the wing are manholes which permit access to the interior of the fuel tanks. Arriving at its allotted place on the assembly line, the center section is lowered and rolled to a horizontal position so that the remaining assembly operations can be completed. Immediately after the wing center section is leveled, the sub-assembled parts of the engine nacelle structure are brought to the front of the wing assembly and the work of their attachment begins. Slid into place and held firmly in place with locating fixtures, the attachment of the nacelle braces and pre-formed skin is made directly to the front spar and center section skin, so that the nacelles become a part of the wing itself. Then follows the operation of fitting the leading edges to the wing center section. Inasmuch as all leading edges and trailing edge sections are completely detachable, drill jigs are used so that replacements may be made with ease in the future life of the boat should the occasion arise. The operations on the wing having been completed, it is now rolled out and heads for the finishing and final assembly departments. Meanwhile, the belt frames and bulkheads of the hull are taking shape. The belt frames are the intermediate formers, while the bulkheads are the main formers. The bulkheads, besides giving form to the hull, also serve to divide it into watertight compartments, so that the airplane becomes a truly seaworthy boat when on the water and, like a surface vessel, is fully capable of coping with any emergency. The building of the belt frames and bulkheads progresses in much the same manner as the building of the spar assemblies. The smaller parts made elsewhere in the plant are brought to the assembly fixtures, placed, secured in position, and drilled. Then, held together with screws, the entire assembly is lifted from the fixture and the riveting operations carried out. When the 2 major bulkheads have been fastened together with screws, they are raised to the vertical fixtures where the workmen may carry on 2 tiers deep the drilling and fitting operations. These are the 2 bulkheads which attach directly to the wing and the wing lift struts. They also form the backbone of the superstructure. With the bulkheads and belt frames completed, the first operation in the assembly of the hull begins. Finished bulkheads and belt frames are lowered into the large assembly fixtures bottom side up, for the first work in the fabrication of the hull is accomplished while it is resting in the upside-down position. Many of these upside-down assembly fixtures stand side by side on the assembly floor, and in the inverted position, the long, graceful lines of the PBY design begin to form as the belt frames, bulkheads, and keel sections find their places and the bottom stringers are added. Plating the hull bottom comes next. To ensure a watertight union between the stringers and the bottom plating, a strip of fabric impregnated with marine glue is laid over the stringers before the skin is applied. To draw the plates down tightly against the stringers while the riveting is carried on, small wooden wedges are used. With the bottom practically completed, the growing hull with temporary truss work to prevent its buckling is raised from the upside-down assembly fixture, rolled to a right-side-up position, and moved to a waiting fixture on the right-side-up assembly line. At this juncture, an excellent idea of the interior construction of the hull may be gained. Notice that these bulkheads divide the hull into 5 watertight compartments so that these boats can battle against inclement weather in the air or ride out bad storms on the surface of the sea. In the right side up assembly fixtures, the upper form of the hull develops rapidly as stringers on the sides and deck are fitted into place. After the stringers have been made fast to the bulkheads and belt frames, the skin is riveted to the structure. Up forward, the cockpit enclosure, an assembly of windows and framework, is shipped and fastened to the growing hull above the pilot's compartment. Aft, the fins are built integrally with the upper portion of the hull and are faired into it. Up on the fin, high above the waterline, providing ample clearance for handling on rough water, will rest the full cantilever stabilizing and control surfaces. From these control surfaces, the steel control cables are brought inside the fin and on down through the hull, away from all spray. The anchor stowage box Anchor winch, nose bumper, snubbing post, mooring walks, and similar surface boat equipment, all material aids in mooring, anchoring, and beaching the craft, are built into the bow. Above the hull in the superstructure, the flight mechanic station takes form. From here, the mechanic will regulate the retracting floats, the majority of the engine controls, and check the engine instruments, thus relieving the pilot to some extent in the handling of this giant craft. Nearing completion on the assembly line, the graceful hulls are lifted out of their assembly fixtures. The fin, superstructure, pilot's enclosure, turret, and hatches have been secured in place, and the hull is ready for watertight testing. The hull is supported on a stout framework, the water poured into each compartment, and the outside of the hull inspected for leakage. The hull department is no small place. As we look down on the assembly line, we gain some idea of the multiplicity of operations necessary in building of hulls for these famous boats. In the foreground, the hulls are but bare skeletons consisting of bulkheads and keels in their upside-down fixtures. The stringers have been added to some, the plating to others. Along the line in the right side up fixtures are stringers on side and deck. Some have plating with sub-assemblies added. Farthest along, the hulls, virtually finished at this stage of the assembly, lack only last-minute additions to their structure and the watertight testing operation before they are ready to leave the department. Immediately following assembly, the hulls are moved to the finishing department and stripped of the priming coat which has served for protection during assembly. This primer is removed down to the metal, but this does not, of course, affect the anodic film protection which was made a part of the metal itself when the material was anodized. After the primer is removed, the hull is washed and rinsed, and then a fresh coat of primer applied so that the base upon which the subsequent finishing coats are applied will be as near perfect as is possible. The wing center section structure likewise receives the same careful treatment when it enters the finishing department. In the finishing department, the application of paint and lacquers is conducted under ideal working conditions. Warmed and filtered air is forced into this department by huge blowers, and a constant positive pressure is maintained so that no foreign matter can gain entrance. Scrupulous cleanliness prevails with all lacquer dust and paint fumes sucked from the paint booths by powerful fans. Such precautions before and during painting ensure that the finish will be of the highest quality and afford the greatest protection possible. Clear airplane dope is applied to the fabric-covered control surfaces, the ailerons and wing trailing edges to pull the fabric taut and add strength to the unit. Tape is doped over the reinforcing tape previously applied over all ribs to ensure maximum strength and smoothness. To facilitate the operation, work of routine inspection and servicing of the airplanes, pertinent instructions and markings are applied to the finished surfaces with decalcomania transfers. These are applied tacky and the paper backing washed off. As the hulls are turned out by the finishing department, they are moved to another section of the plant devoted entirely to final assembly operations. Rolling easily on its beaching gear to its allotted place in the line, the hull is now ready for its wings, engines, and tail surfaces. The wing center section, built for interchangeability and perfect alignment, is brought to the hull and gently lowered on to the superstructure. As it is maneuvered into alignment, the sturdy attachment bolts are slipped home, and the lift struts are attached, holding this portion of the wing securely in place. Brought to the stern of the ship are the tail surface units to be mounted high on the fin. The power plant units are hoisted up and transported by monorail to the waiting airplane, where they are swung into position for attaching directly to the oil tanks at the nacelles with 4 stout bolts. These twin double-row 14-cylinder power plants generate well over 1,000 horsepower each and enable the PBY on one engine alone to maintain full flight with full load. More remarkable, however, is the ability of this same ship not only to take off with one engine, but to sustain flight with sufficient fuel aboard to fly 1,300 miles. The weather which prevails at San Diego the year round is ideal for the completion of many of the final assembly operations out of doors. The nearly completed ships are wheeled out and signaled to their paved yard. Work platforms are shifted into place and final assembly operations are continued. Constant speed propellers, which automatically meet changing conditions and increase the flying efficiency of the airplane, are hoisted to the engines and slipped on the propeller shafts. The outer panels of the wing are brought to the center panel, which we followed through construction, and are attached. These outer panels contain the wingtip floats, and with the integral fuel tanks of the center section, constant speed propellers, and other features, contribute to the outstanding performance records of this airplane. As the planes near completion, United States Navy insignias, numbers, and squadron emblems are added on the hull, the wings, and the tail surfaces for identification. These boats are used by the Navy for bombing, scouting, and patrol work. Flying far at sea, they can maintain close or open formation, as many have done repeatedly in the establishment of the massed flight records, or they can be flown on individual missions. Powerful radios permit constant communication with each other or with shore stations. Contributing to the efficiency of the PBYs are the retractable wingtip floats, which, when the airplane is flying, are retracted into the wing to reduce drag. When down, they serve as air brakes in the approach for a landing, and in addition provide wingtip buoyancy for maneuvering on the surface of protected waters or in the open sea. The PBY design is not only an airplane of outstanding merit, but when on the water is a boat fully capable of coping with any open sea contingency that might be encountered during its operation. The controls are now given a first inspection to see that they are functioning smoothly. The ship is fueled in preparation for starting the engines on their initial 15-minute shakedown run-in. Then, following a second inspection and checking of all the controls and instruments, the engines are given a second run-in of 45 minutes to ensure perfect function. After a final checkup, the plane is ready to leave the plant. From the plant, where the personnel, facilities, and machinery for the building of the most modern aircraft are equal to those to be found any place in the world, have come the PBYs. Delivery operations always attract interest. As the planes are made ready on the ramp for their first taste of the waters of the bay and a delivery, in this case to the United States Navy. The full Navy crew accepting delivery of the PBY climb aboard. The Navy pilot signals the flight mechanic to turn over the engines while he peers out to watch the familiar operation. The Navy operators find the engines take hold easily and begin their run-in for the warming up operation before they signal their readiness to enter the water and the actual delivery takes place. Of the engine controls, the pilot is concerned only with the throttles and propeller governors. The flight mechanic handles the starting, mixture control, fuel flow, engine cowl, flap regulation, and so forth. He also controls the raising and lowering of the floats, receiving his orders from the pilot by means of the visual signal system or the interphone. The beaching gear enables the PBY to be handled with ease on land. It can even operate from a sand beach, and the gear can be removed and stowed aboard with ease. A familiar sight on the bay at San Diego has been the takeoffs of the PBYs, starting the long-distance, non-stop massed flights, which demonstrated their outstanding performance. So far as is known, the PBY is the only twin-engine flying boat which has actually taken off from the water with one engine completely stuck. Not only has the PBY achieved this feat, but it has actually taken off on one engine with sufficient fuel aboard for a non-stop flight of 1,300 miles. An unparalleled demonstration of reserve power. Is it any wonder that these remarkable records have been achieved? The following outstanding flights were made during 1937, 38, and 39. These airplanes, equipped as patrol bombers for the United States Navy, are fast and powerful. Operating from established Navy bases, PBY patrol bomber flying boats can patrol 60 million square miles, 1/3 of the Earth's surface, as the eyes of the fleet in defense of the nation. PBY flying boats daily establish new records as routine operations of the United States Navy. Model 28, as the commercial models are known, have circled the Earth at its maximum circumference, have crossed oceans and continents non-stop, and have operated in climbs from the tropics to the North Pole, all without undue incident. Beyond comparison with any contemporary service type, the PBYs have amazing flexibility. They are completely seaworthy, possess a range in excess of 4,000 miles, and remarkable stamina under all conditions. An outstanding achievement in themselves. These twin-engine flying boats suggest the future potentialities that will emerge from the combined engineering progressiveness, facilities for manufacture, and the building skill of the Consolidated Aircraft Corporation.